Welcome to Deriving the Heat Equation Solution, Part C. So recall, previously, we found solutions U sub n of xt, which were equal to e to the negative an pi over L whole fraction squared t times sine of n pi over Lx. And these satisfy the boundary conditions. So which satisfied boundary conditions of u of 0t equaling 0 and equaling u of LT. So it just remains to satisfy the initial condition. So it remains to satisfy the initial condition of u of x 0 equaling f of x. So essentially what we're going to do is we are going to take a linear combination of all of the u sub n's. So the general solution, we will go ahead and set u of xt to be the sum from n equals 1 to infinity of c sub n times e to the negative an pi over L squared t times sine of n pi over Lx, n pi over L times x, all on side sine. Note, we still have the partial differential equation satisfied. So we still have the partial with respect to t of u is equal to a squared times the partial second partial with respect to x of u. And we also still have our boundary conditions of u of 0t equaling 0 equaling u of LT. So any linear combination, when we plug in x equals 0, we will still have 0 since sine of 0 is 0. When we plug in L, sine of n pi is 0. And so the sum will still wind up being 0. And the linear combination will satisfy this differential equation since it's homogeneous. Next up, we just have to satisfy the IVP. So again, it remains to satisfy u of x0 equaling f of x. So if we just go ahead and plug in t equals 0, we get u of x0 is f of x, and this is the same as the sum from n equals 1 to infinity of c sub n times e to the negative an pi over L whole fraction squared times 0 times sine of n pi over L x. Of course, that e to the 0th just goes to 1. And so we wind up with the sum from n equals 1 to infinity of C sub n times sine of n pi over Lx for f of x. But this is just the Fourier sine series for f of x on 0L. So note, this is the Fourier sine series for f on 0L. And we know precisely what those coefficients are. And so we get that our C sub n are equal to 2 over L times the definite integral from 0 to L of f of x times sine of n pi over L x dx. And so our final solution is that u of xt is equal to the sum from n equals 1 to infinity of C sub n times e to the negative a n pi over L whole fraction squared times t times sine of n pi over Lx, where C sub n is 2 over L times the definite integral from 0 to L of f of x sine of n pi over L x dx. So in the next videos, we will do some examples. I wanted to go through this whole derivation process because you should be able to do this process for different boundary conditions. You should be able to run through the entire process, do the derivation, and find what the solution should look like. If I do not ask you to do the derivation, however, you are welcome to just use the formulas directly. So again, just a quick comment. If I do not specifically ask for the derivation, you are welcome to simply use the formula. Or use the final formula. So, as mentioned, in the next video, we will do just that and take an example heat conduction in a rod problem.